Today we'll discuss some problems on the loop analysis. So this is the diagram for the loop analysis. They can ask the questions in the exam like this. There will be one current source. This is the current source, and here there will be a connected one resistor. So here this is another resistor, and this is the voltage source, and here they are connected to one more resistor like this. This is 10 amps, and this resistance is 3 ohm, and this is 2 ohm, and this the voltage source is 10 volt. This is 10 volt, and this resistance is 3 ohm. In the exam they can ask the question like this: write the mesh equation for the circuit shown in figure and determine mesh current using mesh analysis. You also assume the loop current. This is the one loop current, that is called it as a I1. This is another loop current, this is I2, and assume this is another loop current I3. So in this diagram, the assumed current I1 is same as the existing current 10 amps. Therefore, I1 is equal to 10 amps. In this example, assumed current I1 is in same direction of the existing current 10 amps. Therefore, I1 is equal to 10 amps. Next, apply KVL for the loop 2. Apply KVL for loop 2. Write the equation now. So 3 into the current flowing to that branch is I2 minus I1 plus 2 into current flowing to that branch is I2 minus I3. I3 minus I3 becomes I3 is in opposite direction of I2 plus 10, that is equal to 0. Simplify this expression. 3I2 minus 3I1 plus 2I2 minus 2I3 plus 10 is equal to 0. Already we know the I1 value. Substitute this I1 value. 3I2 minus 3 into 10 plus 2I2 minus 2I3 plus 10 is equal to 0. This is 5I2 minus 2I3 is equal to, this is 30 minus 30 plus 10, that is minus 20 equals 20. Call this equation as a 1. Similarly, you apply the KVL for the loop 3. You have to apply KVL for loop 3. Then you can write an equation like this: 2 into I3. I2 is in opposite direction, therefore you have to take 2 into I3 minus I2 plus 3I3, okay, minus 10 is equal to 0. This you rewrite minus 2I2 plus 2I3 plus 3I3, that becomes 5I3 is equal to 10. This is the second equation. Now solve the equations 1 and 2. Solve the equations 1 and 2. Then you'll get the I2 value will be I2 is equal to 5.7142 amps, and then I3 is equal to 4.2857 amps. Next, you consider another problem that is like this. This is the one more problem, and here it is like this. This is positive, negative, and here they're connected like this. Here it is connected one current source that is 3 amps, and here it is from here to here and here that is positive, negative, and here one more that is voltage source. This is positive, negative. Okay, this is 2 amps, 2 amps. This is 0.1 volt, 3 amps. This is 10 ohm, and this is 5 ohm, and this is 20 ohm, 24 volt, and this is the V2. So they can ask the exam in the exam question like this: use mesh analysis to determine what value of V2 in the network shown in figure causes the voltage V is equal to 0 volt across the 20 ohm resistance. So you can assume the loop current. Here I can assume the loop current like this. This is where I1, okay, and this is another loop current that is I2, and this is another loop current, it is I3, and here another loop current, it is I4. So in this diagram, I3 is in the same direction of existing current 2 amps. Therefore, we can write I3 is equal to directly 2 amps. And I4 is in the same direction of existing 3 amps current. Therefore, we can write I4 is equal to 3 amps. Now we can apply the KVL for the loop 1 and loop 2. Now apply KVL for the loop 1. Apply KVL for loop 1. Then we can write an expression like this: 10I1 minus 10I3 plus 20I1 minus 20I2 minus 24 is equal to 0. Further you simplify this, then you can write it as a 30I1 minus 20I2 minus 10I3 is equal to 24. We already know the I3 value 2 amps, that you can substitute here. 30I1 minus 20I2 minus 10. I3 value is 2, that is equal to 24. So this we can write as 30I1 minus 20I2 is equal to, is a 20, and this 24, that becomes a 44, and this call this equation as a 1. Next, apply KVL for the loop 2. Apply KVL for loop 2. Write a equation: 5I2 minus 5I4 plus V2 plus 20I2 plus 20I2 minus 20I1 is equal to 0. You simplify this: minus 20I1 plus this is 25I2 minus 5I4 is equal to minus V2. Substitute a value of I4 is a 3 amps, minus 20I1 plus 25I2 minus 5I4 is 3 amps, that is equal to minus V2. So this is minus 20I1 plus 25I2 minus 15 is equal to minus V2. So further we can simplify this. We can write like this: 20i1 minus 25i2, that is equal to V2 minus 15. Call this equation as a 2. The drop across 20 ohm is 0. Drop across 20 ohm is 0 is a given data. The drop across the 20 ohm. What is the voltage drop of the 20 ohm is 0. That is V is equal to I into R. What is the current flowing through that branch? That is 20 ohm resistance. The current flowing through that resistance is I1 minus I2 into resistance is 2. That is a voltage across this, that is equal to 0 is given the data. So this you can write it as I1 minus I2 is equal to 0 by 20, that is equal to 0. Then we can write I1 is equal to I2. So from equation 1, substitute I1 is equal to I2, then we can write it as 30I1 minus 20I1 minus 20I1 is equal to 44. That is 10I1. 10I1 is equal to 44. Then I1 is equal to 4.4 amps. 4.4 amps. That is also equal to I2 value. So from equation 2, we can write it as 20 into 4.4 minus 25 into 4.4, that is equal to V2 minus 15. Then the V2 is equal to minus 7 volt. Thank you.